another lecture of Industrial Wastewater Treatment course, where we are discussing about processes and treatment of wastewater from various industry. In the last lecture, we talk about industrial wastewater from tannery industry, and which is also known as non-agro-based industry. Today in this lecture, we'll talk about treatment of wastewater from tannery. So the content of today's lecture includes treatment of wastewater, treatment of flow sheet, waste minimization and byproduct recovery. Okay. So already we have discussed the characteristics of wastewater from tannery, where we segregate spent tan liquor, whether it is waste tanning or chrome tanning, and remaining wastewater is then subjected to treatment in ETP. The spent tan liquor from vegetable tanning or chromium tanning, it is treated separately. Okay. So here we are talking about treatment of remaining wastewater, which requires primary as well as secondary treatment. Primary treatment includes screen for removal of hair and floating body tissues, then grit removal, and then wastewater is taken to equalization tank. Here aeration is needed because wastewater is readily putrescible and immediately anaerobic condition will arise. The next treatment can be plain sedimentation, which gives quite good efficiency with 40 to 50% reduction in BOD and 80 to 90% reduction in TSS, but the HRT required is quite long, 24 hours. Another option is go for coagulation, flocculation and settling, where the HRT may be 3 to 4 hours. This gives higher reduction, BOD 55 to 60% and TSS up to 97%. So with this, primary treatment is completed and wastewater is subjected to secondary treatment. So we have two options, either go for aerobic treatment or anaerobic aerobic combination. So various aerobic treatment suitable for treating wastewater from tannery includes trickling filter with mixing of sewage. Efficiency up to 90% for BOD reduction is achieved. Activated sludge process, 85 to 95% efficiency, but the HRT required is once again high, 24 hours. Since initial BOD is high, so the aeration cost is also quite high. Next option is aerated lagoon, little cheaper option, but HRT 3 to 5 days. They give efficiency 70 to 90% for BOD removal. And yet another option is oxidation ditch, which can give efficiency up to 95%. Now, instead of going directly aerobic treatment, which are quite expensive, we can give combination of anaerobic and aerobic treatment for tannery wastewater. So for anaerobic treatment, most preferred is anaerobic digestion, where you can reduce BOD load and at the same time there is a potential of energy recovery in form of biomass. Okay. So BOD at the inlet of digester can be high up to 15,000 milligram per liter, and at the outlet it can be reduced to 500 milligram per liter. So efficiency quite high, 85%. Another advantage is that the biogas generated during this anaerobic digestion, it has very high methane content, 85%. That means its calorific value is quite high. Another option is anaerobic lagoon, but no biogas recovery, 70 to 80% efficiency. Yet another option is use of UASB, upflow anaerobic sludge blanket, with short duration 12 to 16 hours. This also can yield biogas with a methane content 80%. So it's a very good option, but UASB has certain drawback that its performance is poor because of high concentration of sulfide and sulfate in wastewater. Now, whenever we use anaerobic process, it must be followed by aerobic. So, either in case of anaerobic digestion or UASB, the treatment is further followed by ASP or aerated lagoon. So, here on your screen, you can see the treatment flow sheet for tannery wastewater, which is without spent TAN liquor. So, screen, grit, equalization tank with aeration and plain sedimentation, it is up to here primary treatment. Secondary treatment, anaerobic lagoon, HRT 10 days followed by aerated lagoon, HRT 6 days, and then your wastewater is treated post disinfection, ready for disposal. Many times the tannery wastewater meets all specified standard for wastewater except total dissolved solid because of high salt content. Lot of salt is applied on skin and which is removed during process. So, all this salt ends up in wastewater. Hence, wastewater may not meet the standard for TDS 2100. In such case, wastewater may require tertiary treatment. So, tertiary treatment in form of pressure filtration, advanced oxidation process, reverse osmosis required or given, and then your wastewater, it is such a fine quality that instead of disposing, industry can reuse this wastewater in the process. So, if tertiary treatment is given, then wastewater is recycled or reused. Right? Now, many tanneries, they are located in small cluster or some industrial estate. Individual tannery is small scale and they cannot afford to give treatment, full-fledged treatment. But there are multiple units and collectively the wastewater is such a hazardous in nature that it cannot be disposed of. So, common effluent treatment plant, a scheme by central government, is very popular and very suitable for treatment of wastewater from tannery. So, there are various CETP all over India, but maximum CETPs are in Tamil Nadu for this tannery waste treatment. Here pre-treatment is given by individual unit and then the effluent is sent to CETP where primary, secondary and tertiary treatment is given, and at the outlet of the CETP, BOD standard 30 mg per liter and COD 144 mg per liter is achievable. So, CETP is very popular alternative for small scale tanneries. Okay. So, let us go into the last point of treatment, that is waste minimization. So, for process substitution, we have very good scope. Instead of caustic or instead of lime for this lime process, you can use caustic or enzymes. So this will reduce entry of lime and hence burden on ETP will be reduced. Then one very good process substitution is, instead of salt, you can use refrigeration of skin. So no salt to be applied and no salt will enter in the wastewater. The yet another option is, instead of soaking the skin with salt in soak pit directly, try to dust off or dry remove the salt, which will considerably reduce TDS content. Observing good practices like avoidance of spill and leaks from wet, dry cleaning of floor, that is also useful. Recycling and reuse, there is a good potential. The spent tan liquor, you can make its strength, and then instead of throwing, you can use true science reuse for the next batch of tanning. Then segregation of wastewater from batting and prickling process, and then you can use this wastewater stream for soaking of skin or floor washing after neutralization, and then reuse of treated wastewater for process after advanced treatment. So these are some of the scope for waste minimization. The tannery industry also offers very good scope for byproduct recovery. Number one is recovery of salt. About 275 to 300 kg of salt you can recover per ton of skin process. Even from wastewater you can recover salt by going for solar evaporation. The wastewater from fleshing, which contains body tissue, and you can use it for development of aquaculture as a food for fish, or you can recover the cattle feed. The hair, which is solid waste from tannery, you can use it for manufacturing of paint brushes or as binder. The trimming, which is cutting of leather for giving proper shape or thickness, that's also known as saving. You can use it for recovery of glue and gelatin. So these are the various byproduct you can recover from this tanning industries waste. So here we conclude our discussion on treatment and waste minimization of tanning industry, and in the next lecture we will start with yet another industry, that is meat processing industry manufacturing process. So thanks everyone.